To convert degrees to radians, we have to think about, okay, so a full circle would be 2 pi radians, but we don't have the full circle. So what fraction of the circle do we have? We have 325 degrees out of 360 degrees total. So again, this part finds the fraction of the circle we actually have, and once you have the fraction, you multiply it by what a full circle would be. So same thing for B. We first find the fraction of the circle we actually have, multiply it by what a full circle would be. Okay, to convert radians to degrees. So we have to think about where this answer would come from. So this is what a full circle would be in radians. But we don't have the full circle. We have some amount of unknown degrees, which I'll call x, out of 360 degrees total. And the answer is 0.68. So you need to solve this equation for x. Okay, so maybe I'll multiply both sides by 360 to get it out of the denominator. And then divide both sides by 2 pi. Okay, so then you use your calculator for this, and it is approximately 38.96 degrees. So same process for B. A full circle of radians would be 2 pi, but we don't have the full circle. We have some unknown amount out of 360. And that fraction of the full circle becomes 5.8 radians. So again, solve this for x. And set up a similar equation for part C. Full circle, multiply it by what fraction of the circle you actually have. Solve for x. Convert radians to degrees. So a full circle would be 2 pi radians. But we don't have 2 pi radians. We only have a fraction of it. So what fraction do we have? Well, some unknown amount of degrees out of 360 degrees in a full circle. And this apparently equals pi over 2. So now we need to solve for x. So I'll multiply both sides by 360. And divide both sides by 2 pi. So you would use similar setups for the next few problems. Full circle times unknown out of 360 equals 10 pi over 3. Okay, so you would have to solve each of these for x by following a similar process. What is the sector area intercepted by a central angle? So let's see, we got a circle, we got a central angle. That measures 2 pi over 3 radians, and the radius is 5 inches. Okay, so this is the area we care about. So first we figure out what would the full area be. So full area would be pi r squared, in this case pi times 5 squared or 25 pi. But we don't have the full circle, we only have this amount of it. So what fraction exactly do we have? Well, the full circle in radians is 2 pi. But how much do we actually have? We only have 2 pi over 3 out of it. Okay, so now we need to simplify. So let's simplify the fraction first. When you have a fraction within a fraction, you have to do fraction division. So I'll do that off to the side. So the numerator comes first, and then I'm dividing by the denominator, which I'll write as a fraction. So to divide fractions, we multiply by the reciprocal of the second number. First fraction stays the same. Okay, so it looks like this fraction simplifies to 1/3. So the full area would be 25 pi, but we've only shaded in 1/3 of the circle. So the actual area is 25/3 pi inches squared. Okay, central angle measures pi over 5. And the radius is 20 miles. So if the central angle is pi over 5, its intercepted arc is an equal measure, so also pi over 5. And we're looking at arc length this time, so that means we're working with the circumference. So the full circumference would be 2 pi r, and in this case 2 pi 20, so 40 pi. But again, this is the full circle. We don't have the full circle. We have, out of a total of 2 pi radians, we've only got pi over 5. So let's simplify this fraction. Pi over 5 divided by 2 pi over 1 becomes pi over 5 times 1 over 2 pi becomes 1/10. So we only actually have 1/10 of the circle. So the full circumference would have been 40 pi, but we only have 1/10 of it, so the amount of arc we actually have is 4 pi miles. Okay, circle with radius 10. What is the area of the sector intercepted by a central angle of 13 pi over 10? So we're talking about area, so what would the area of the full circle be? Pi r squared. So the full area would be 100 pi, but what fraction of the full circle do we have? We have 13 pi over 10 out of the total of 2 pi. So let's simplify this fraction. 13 pi over 10 divided by 2 pi over 1, multiply by the reciprocal of the second number. We can cancel out the pi's, so we get 13 over 20. So 100 pi times 13 over 20, we get 65 pi. Central angle measures pi over 6. Radius is 3.5. Find the measure of the arc intercepted by the central angle. Well, the central angle and the intercepted arc have the same measure. Okay, so remember that measure of the arc is in degrees or radians. It's not a unit of distance like millimeters. So the answer is actually just pi over 6. Or if you want to write it in degrees, that'd be 30 degrees. Central angle of a circle is pi over 3 radians. Measure of the minor arc is 7 inches. Find the radius. Okay, so we're talking about arc length, so that means I want to know about the circumference. So the circumference is 2 pi r. I don't know what the radius is, so I have to leave it as r for now. But again, that would be the full circle. Because I don't have the full circle, I need to multiply by whatever fraction of the full circle I actually have. So the full circle is 2 pi, but I only have pi over 3 of it. And this leads to the arc length of 7 inches. Okay, so let's do some simplifying. Pi over 3 over 2 pi becomes pi over 3 divided by 2 pi over 1, multiply by the reciprocal of the second number. We can cancel out the pi's, so we get 1 over 6. And now we need to solve for r. So 2 times 1/6 is 1/3. Keep the pi, keep the r. Multiply both sides by 3. Pi r equals 21. Divide both sides by pi, and we get the radius is 21 over pi, and the units are inches. Find the length of the minor arc of a central angle that measures 2.5 radians if the radius is 3.2 inches. Okay, so we're working with minor arc's length, so that means we need the circumference. So 2 pi r becomes 2 pi, the radius is 3.2. So the full circumference of the circle is 6.4 pi, but we don't have the full circle. Okay, how much of the circle do we have? The full circle measures 2 pi radians, but we have 2.5 radians. Okay, so let's simplify this. Turn this into a fraction. We can cancel out the pi's. 6.4 divided by 2 is 3.2. And then multiplying these, we get 8. Okay, so the units are inches. Sketch a circle. Inside your circle, sketch a central angle that has a measure of approximately 1 radian. Okay, so remember, radian is based on radius. So if this is the radius, I need an equal distance along the edge of my circle. But remember, obviously the radius needs to bend to fit the circle. So I'd say it's approximately this much. And then I just need to complete up my angle. Okay, write 2 sentences explaining why I think my sketch is accurate. So, well, the definition of a radian. Okay, so again, if let's say we started over here, we started with the blue arc only, and I knew that this distance was 1 radius, then I would connect both those points to the center, and that distance I created would be 1 radian. Okay, so that's one sentence. So second sentence. And then I guess I can use estimation to know why my sketch is accurate. So I know that there are 2 pi radians in a full circle. And 2 pi is approximately 6.28. So that means I should be able to fit a little more than 6 radians in my circle. So if I duplicate my sketch 6 times, I do see that I have room for over 6 of these.